Good morning, everybody. I hope today finds you well and your laser even better. But if not, this video is about aligning your mirrors. And I've seen quite a few videos demonstrating this on YouTube. And in my opinion, and this is just my opinion, but maybe it's more than just an opinion, the approach is wrong, because what everybody suggests is that you try and line up your dots, right? And when they're doing that, they're like, and try and make it hit in the center of the mirror, right? So often what you'll see is that somebody will tell you, yeah, you just stick a piece of paper, a piece of tape, or a piece of receipt paper, right? Something that you can see a marking on, and just put it right in front of your mirror and try to get that dot centered, and then move it over here and make another dot. And if the two are misaligned, then, you know, twiddle with your number one mirror back there by the laser tube and try and get them to line up, and just keep repeating that until the two dots are in the center of the mirror. The problem with that is that it makes the assumption that the center of your mirror is already collinear with the laser beam axis and the gantry, right? Because the mirror's movements through space are governed by this rod right here, and to a lesser degree by where it's held over here. But pretty much the travel direction, and this is both vertically and horizontally, the travel of this rod is what determines where this mirror moves in space. And so if your laser is not also collinear, I suppose is the word, or parallel, both in the horizontal and vertical axes, you're never going to get those two dots to lay on top of each other and to remain there in the center of your mirror. The correct approach is to forget that the mirror is there, okay? Initially, you want to just forget that the mirror is there. You want to get a large enough target that you can catch the beam, you know, in any place around here. And if your mirror is terribly misaligned, you know, that beam could be shooting out here. And I've actually misaligned mine on purpose to that degree, just to mess around with things before, and it actually zapped me right in the gut. But yeah, I'll forego the laser safety talk. You guys should probably know that by now. Okay, so I'm going to tell you a little bit about this machine to sort of instill some confidence in you about what is possible with mirror alignments when your frame isn't square and all that kind of thing. This particular machine, I bought it broken, and in fact it's probably still a bit broken, I guess you could say. What happened was that during shipment, it's very well packaged. I mean, they come in a lot of foam. The problem is these casters down here are basically not protected because they're laying at the bottom of the box. They're not foamed in with the rest of the enclosure. The rest of the enclosure is beautifully wrapped in foam when it comes from China, but those casters are touching the bottom. And these boxes get thrown around, and what happens is those casters get pushed up in the sheet metal, right? This sheet metal is very thin. And so this machine got crushed, it got bent. Let me see if I can show you. You can see right now, these two doors don't even line up because, you know, the frame is sort of twisted. You can see there's a fracture there. This hinge is actually broken. If I move this around, you can actually pull that hinge out. So, not a perfect machine by any stretch, but I was able to fairly easily align the laser with minimal adjustments to anything other than I did take my gantry out and I banged on the sheet metal to get it all nice and straight, because it was crushed quite severely in this corner over here. Anyway, so that's basically a long-winded way of saying that if I can do it, you can do it. Okay, so without further ado, let's start disaligning this laser. Actually, let me demonstrate how well aligned it is first, since we want to really mess this guy up. I'm going to show you a little jig that I did on this piece of Post-it note. Now the adhesive part is just beneath this, and you can see there that I have a 12 millimeter line drawn above the edge, and then I have another line drawn vertically now. You can already see I've burned a dot there. So on my laser nozzle here, I have a little scratch line that I just eyeballed in the center of the hole. It's a bit of the chicken before the egg, because this is also one of those components that need to be aligned, right? If you have too much twist of this in one direction or the other, that is, this mirror in the background twists that way or that way, your beam, instead of going down at a 90 degree, it gets deflected, you know, off in that direction. If you have one of those incorporated air assist nozzles, where it's very critical that your beam go right through the center, you're going to be hitting the side of that nozzle, and you're going to get half moon shapes, or if you're using a 3D printed nozzle, it's going to burn a hole in it. If you don't notice it, you may just keep using the laser and not even notice that the air assist got a hole burnt in it. But for now, let's just forego any assumption that this is aligned or misaligned, and just know that I scratched a little line on the plate so that I know where the center is, so that when I place my Post-it note there, right, I just try and line it up with that, and that just helps me know, okay, I've got my marks there, my center line is presumably directly in the center of that mirror. And I guess I should say, yeah, the 12 millimeters for a stock nozzle is roughly in the center of the hole. So vertically, that is, it's 12 millimeters off the base to the center of that hole, and that's really where you want to get your shots, somewhere within 1 or 2 millimeters of that. The closer you get to the mirror's edge, the more likely it is that you're going to you know, hit an edge and lose some of your power. You want to keep the center, the power in the center of your mirror, so that you get as much of it down to the lens. Alright, so I'm gonna have trouble making another one of these without putting down the phone, so let me just, well, I guess you can sort of see I've already set my caliper. It's at 12.4142 millimeters right now. I'm just going to use that, and I'll just, what I'll do is I'll take that and I'll drag it across here and make that line, see? Okay, so you can see that line. And then I'm going to put a fold in the top, and that's just to stiffen it up, you know, so that the page doesn't sag, since I'm not going to be wrapping it around the mirror. I'm just going to be tacking it on to the front. I could get fancy and put the lines back in here, but let's just take a shot and see that it's right on the 12 millimeters. So I'm going to put it in the worst case position first, which is to the right and to the front of the machine. I've got my power set at 9. I'm actually going to lower it down to 8.5, because I know that that doesn't immediately make a mark in the paper, so it requires that you hold the laser a little bit. That gives you time to get your finger off before you actually burn a hole in it, so you can make a comparison. Wow, that's taking a really long time. Alright, I'll bump it up. 8.5, 8.6, 8.7, 8.8, 8.9. Okay, there, the dot is starting to appear. Can you see that? Yeah. Alright, so that's worst case scenario. We'll move it here to the near side. A little bit high. And best case scenario, as close as possible to the head. strong. Okay, so a little bit of misalignment there on the x-axis here. From here to here, there was a little bit of misalignment. Now, in the morning, that was perfectly okay. But one thing that I did is I did move the machine, and that's one important thing about these. This sheet metal on the bottom has no support whatsoever. So moving your machine around, I mean the sheet metal in general is all that thin. So moving the machine around can create some misalignment. So if you're going to keep it on the casters, it's best to you know, make it so that they don't move around. The casters have a couple of breaks. Otherwise, you can just take the casters off and lay it directly on a flat table. But anyway, so a little bit of misalignment there. As you can see from my previous test, and this was before I moved the machine, and I was pressing down on the laser tube to see if it was tight in there. You can see it was very well aligned. And that's what we're going to shoot for. But first, what I'm going to do is I'm going to misalign these guys and talk a little bit about what each screw does. So I like to start with the mirrors squared out. You don't have to. You can probably start with just how it was when it came out of the box. But yeah, so I'm going to misalign that guy. All right, so that should be like totally off of the mirror, I think. And let's go to the back where the laser tube is. Now, one adjustment that would be really handy, and I'm going to talk about this back in the front for a minute, is to be able to move the laser tube itself for alignment purposes. So in my machine, the tube is actually sitting about 1.5 or 2 millimeters higher than where it needs to be relative to mirrors number 2 and 3. Mirror 1 obviously doesn't really matter too much because it's so close, but the result of that is that everything downstream has to be shimmed up for me to hit in the center of the mirrors. And so I'll show you what I did there before we get into the alignment. So if you look on this guy, I don't know if I can show it properly, but I have a couple of nuts on the bottom, and these are 4mm M4 nuts, and these are M3 screws, so the nuts are kind of loose in there, but I'm using them to shim up the entire laser nozzle to catch that beam. And you're going to hear me say that, catch that beam, a lot, because that's really what you're trying to do when you're lining up your mirrors, is you're trying to move them into a position where they catch the beam, and not trying to force the beam to hit the mirror. Okay, so we start with mirror number 1 here. So first and foremost, before any kind of alignment adjustments on number 1 mirror, what you want is you want to ensure that the laser is hitting in the center of that mirror. And to do that, you want to start with low power, because in this particular case, you would want to put the paper very close to the mirror, and if you create any smoke there, it's going to foul your mirror, and you're going to have to constantly be taking it out to clean it when the smoke hits back there. So let me go back to 8.5. I think it should be able to make a mark here. Again, I'm just going to eyeball it here, because I'm not really going to take mirror number 1 out of alignment, just to make this video a little bit shorter. I guess 8.5 just doesn't cut it these days. Now, you guys can't see this, but I'm wearing safety glasses, and that's very important, especially when you're working back here in the back. At higher power levels, the tube will emit a lot of UV light, and you definitely don't want to get that on you. All right, so we have our dot there, and you probably need to take a measurement from the edge to that dot, and a measurement from the from the base of the mirror where you put the edge of the paper to see that it's centered. But you know, I just eyeballed it, and it's pretty much centered in there. So again, my laser is sitting a couple of millimeters up off the axis, right? So when I go to catch that beam, I guess I will misalign axis number 1, 2. When I go to catch that beam, I don't care about this guy. All I want to see is that my 2 dots are hitting each other. That's the primary concern. You don't want to worry about the centering of the mirror yet. Okay, so let's just zap a couple of holes in here. Actually, let me misalign mirror number 1. Let's see, we'll make it a diagonal misalignment. So this screw right here will hopefully push. This is going to push the dot diagonally down. Alright, so let's see where that hits. Alright, so we have our first mark. And again, we're not worrying at all about where that is relative to the center of the mirror. We just want to see where is the laser putting its dots. Okay, so you can see there is a misalignment. Now, the nominal position is going to be very close to where this back dot is, right? The dot that you get when you push the machine back, that's where your ideal position is going to be. It's going to be a little bit higher because we're moving diagonally in that direction with our misalignment. So, but what I guess I'm trying to say is that dot is going to move very little, and the other one is going to make the majority of the movement. So I'm going to replace the paper now, and I'm going to put a fresh one in here, and hopefully try and make a smaller dot there. Again, not worrying at all about where that is with respect to the center of the mirror, but more importantly just to get my reference dots there. Let's see if I can. Now, one thing I've done in the past is I wet the paper so that I can control the burn a little bit better. Sometimes it runs away from me. Alright, so there I just got the faintest hint of a dot, and I'm going to move all the way over here. And I should have taken off the door. Let me take off the door because otherwise I can't reach back there. Just put the phone down for a second. Okay, and if you're just joining now, I'll reiterate that I'm wearing safety glasses, so this is not something that you want to do frivolously, and you also don't want to put your phone right in the path of the laser. Alright, so let's make one dot, and then we will start moving our test result in the direction of the other laser. Okay, so as I mentioned, this is the screw that creates diagonal movement, right? So it goes from upper left to lower right, lower left to upper right. So right now my misalignment is towards the lower left, as seen from the front of the machine. So I'm gonna from this direction, if you're looking from this direction, I'm gonna rotate counterclockwise to back out that screw slightly. I'm just gonna do about 1/8 of a turn, and then I'm gonna burn that dot again. And you can see that the dot is moving. So I'm gonna do it one more 1/8 of a turn. And you can see it moved again. I'm going to replace the paper, put out that little ember, make sure you don't set your garage on fire. And yeah, I'm actually going to dip my finger into the well water here and wet the front of this so that we can maybe see the burn mark without totally, you know, setting the thing on fire. Okay, so I'm going to zap it one more time in the back. See if I can get that. There it is. And now we will put it to the front. Okay. So now we have a little more to go. Pull it back back to the front, zap it. Okay, so we overshot. Okay, getting there. Now as far as lining up the dots, so the reason why I'm making this video is because if you're trying to line up the dots to the center of the mirror, and your mirror is not, like I said, already in that center, in that path, you're never going to get the two dots to line up, and so you're going to be chasing your tail, or you're going to settle for a partially aligned setup there. So this is why we don't take the mirror into consideration initially. What we're going to do is we're going to get these two dots to fire up directly on top of each other, and then we're going to shim this mirror and move it up and do whatever we need to get it into the path. Now, alright, so those two are hitting right in the center of each other. Now, as I mentioned, I've already shimmed up my mirror, but I'll tell you what was happening for me, because my laser tube is sitting a little bit too high. Okay, so when you have proper alignment, that beam that is traveling from the laser, the beam that is traveling here, is traveling in the same direction as this rod that you see here. And I'm not saying that it's coming down here, I'm saying it's going in the same direction to infinity. These two lines will never converge. They will simply just keep traveling in parallel in that direction. I mean, theoretically, right? It's a very close alignment, let's put it that way. So now that I've got my two dots aligned, my mirror may or may not necessarily be lined up to that beam, right? So that's when you go to the next step and try and catch that light. Now this is the part that I hate to do. So I really do want to wet the machine, wet the paper, because I don't want to foul my mirror. And if you like, you can put a little piece of aluminum foil or something back there to keep the smoke from getting back there. But so I'll just zap it a little bit and see where that dot lies. Alright, so I have my dot there. Now I really do need 3 hands. I'm gonna put this pen roughly where the dot is. Okay, you can see that there. And then I'm going to remove the piece of paper and see where that is relative to the mirror. Alright, so you can see that relative to the mirror, I'm actually hitting quite close to the edge. Alright, so I want to bring that mirror this way. Wow, I'm really surprised that I screwed up the alignment that badly. But hey, what can you say? Alright, so to do that, where's my handy dandy tool? I am going to loosen these 2 screws and then just, oh, you know what, that mirror is not going to move any farther over. It's as far over as it can get. So that brings up the, that moves a little bit. The next point of alignment, and that is if you can't get your mirrors, you know, simply through their adjustments to line up with your dots where they exist in space, then what you have to do is you have to move your gantry. It means, so in my case, the beam is hitting you know, a little bit to this side, right? And my adjustment here is already all the way over in that direction. So the only other option that I would have is to loosen the bolts where my gantry is screwed down to the machine and push the gantry towards the left wall. And given that I am at the limit of adjustment here, I think that's probably a good thing to do in my case, would be to loosen these 4 bolts and then push that gantry all the way against its limits there. There's a slightly bigger hole, so you can move about 3 or 4 millimeters in any direction and skew it a little bit. But you know, again, that's not something I want to do with just one hand and holding the phone. So let's just check what our final alignment looks like with the laser hitting there. Maybe it's totally off now. Not the greatest video to instill confidence, I guess, if I leave it misaligned by the end of the video. But yeah, see, so now I'm hitting way on that edge. And I think on this side I'm not even on the paper. So let's see how far off it is. Yeah, so you can see the... Now here I adjusted 2 axes, so you can see the laser is traveling down in that direction there. Okay, so again, the way to address that is if you're getting a diagonal movement, you want to back out the diagonal screw. Now I misadjusted 2 screws there. Okay, so we're getting really close to the line there. Let me see where my close dot is. Okay, it's right in the center too. And then over here I think it's going to be either straight up or straight down above that. No, we're not even hitting the target. Okay, so as far as misalignments go, this, well, either that or I'm hitting right through the center of the hole. Let me put another piece of paper there. Yeah, that's kind of why you don't want to burn through the paper. It makes it a little difficult to see if you're hitting the same target. Come on, give me a good little brown spot. There you go. There you go. Alright, so looks like it's hitting a little bit high. It's not hitting it all there. So we've got enough divergence. Oh, it is hitting. Okay. It's just not easy to see. Alright, so yeah, we're still roughly hitting in the same spot. But when I remove that, like keep an eye on where that is, you'll see it's, you know, it's right up here at the top of the thing. So probably when I pushed down on my tube this morning, I probably changed the alignment a little bit. I was messing around with these rings to see if there was any give, and I didn't notice any. But now that I'm looking, I see that the tube actually moves when you do that. So that's probably the source of this misalignment. Part of what it's done is it's made it so that this side now needs to go down and this side needs to be shimmed up a little bit. Alright, so let's see, where's the next best place to start? Alright. Do I have any tools nearby? Tools? Alright, I'm going to put the phone down and grab a little wrench. I'm actually going to move the gantry. I'm not going to leave you guys hanging. We're going to do this alignment. We're going to do it properly. I keened them for a wrench. Alright, we took the other tool bag. Tool bag. Come on. Freaking kids in the garage, man. Yeah, so I'm blaming the kids, but the tool bag is right here under the laser, actually. Alright. There we go. This one will work. Alright, so I'm going to loosen these guys up. Later today I'm getting a ZBed, so I'm gonna have to take all this out anyway. But knowing how the post delivers around here, it may be 8 p.m. before that thing gets here. Let's see here. Where's that other? It's telling me I can't rotate my device. All right. Yeah, what we're doing here is we're shifting the gantry so that we can catch the light in the mirror. Not trying to adjust mirror number 1 to hit in the center of mirror number 2. Just getting those 2 dots lined up and then doing whatever is necessary to get mirror number 2 to move into the center of that beam, because the beam is now collinear with the y-axis from mirror 1 to mirror 2, and that's the critical thing about proper alignment, is that you need the beam to be on axis. Then the mirror alignment, quote unquote, is actually a mirror placement within the path of the beam. And if you're a Stephen King fan, then you'll get that reference. Wow, this last screw is the nut is really hard to get to. I'm gonna have to stick my head in the laser. Maybe I should turn off the beam. Alright, so let's see if it moves at all. There we go. Alright, so that's about 4 millimeters. Okay, so that's going to buy me about 4 millimeters of travel here, right? Because, wait, is that correct? Or do I want the... I'm all the way this way. Yeah, I actually want to go in the other direction. I want to be farther away from the wall, because the beam was here, so I want to bring the mirror that way. Right on. Alright. So I pushed the gantry all the way to the other side to give me as much adjustment on this bracket here, where you see these adjust screws, because as you can see, it's already right against the edge, so there was no more adjustment possible there. Now before I tighten these down, I'm going to take some measurements with the caliper and see just where that is sitting. Do it from this edge. Alright, so that's 118.85 millimeters. 116. 118. So 118 in the back. 116, 114, no, sorry, 116.53 back there. 118 in the front. That's what I meant to say. Alright, so I don't know. I'm at 2 millimeters. You can certainly compensate for that with mirror number 1 there. But since we're here, what I'm going to do is, let's see, 18 in the back, which means we want to bring it closer. So I'm going to tighten up one of the nuts in the back, which is at 116 millimeters. I'm going to tighten that guy down. I'm going to take these standoffs off. Getting the ZBed, as I mentioned, so won't be needing those in there anymore. Alright, so I'm gonna tighten this guy down, and that's gonna let me rotate the bottom part closer to the wall to get rid of some of that 118, get it closer to 116 millimeters. properly tighten this. Alright. Okay, let's take our measurements again. I'm measuring from the inside edge to the wall. 116.2 millimeters. This should still be 118. Okay, now I'm going to give it a nudge. Reset our caliper. Take another measurement. 117.25. Give it another nudge. Of course, the other side is also going to be moving towards the wall slightly. Not a big deal. We're going to keep checking both sides. 115.75. 115.64. I'm going to call that square. Okay, so then I'm going to tighten this guy first, lock him down. We're within 1 millimeter of being square relative to the enclosure. It doesn't mean we're square relative to the laser. As far as we know, the laser is more than 3 off. Okay, so I'm going to drop the phone again, put that guy in, and where did I put this wrench? So now we'll check the alignment again on the 2 dots from mirror 1, and then we'll loosen up those 2 M3 nuts on mirror 2 and get him lined up with that axis. Alright. Let's check our measurements once again. What is that? 115.9. 116.16. Okay. Pop another Post-it onto the bracket for mirror 2, not onto mirror 2 itself, because again, we're never trying to line the dots to the mirror. We're trying to line the dots to each other. Okay, we'll zap it once. Wait for the dot to develop. There he is. Move it to the back. Okay, so now we've got a left to right adjustment to make. So the close dot is on the left and the right dot is the bottom dot. Wait, the front dot is on the right, the back dot is on the left. So we need to move our mirror more to the left, and there's not much diagonal there. So for a straight left to right movement, what you want to use is this guy over here. This gives you left to right movement, and to move it more to the left, we want to back him out ever so slightly. Zap it again. Oh. Very close. Alright, so now we've crisscrossed. Let's just move the paper over. Let's get our first dot again. Yeah. Make a small backing out adjustment. little bit more. Okay. Now we're really getting very, 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 very close to being truly aligned there. Do one more dot. A little teeny tiny bit more. Okay, overdid it just slightly. Alright, so the dots are aligned vertically, but not horizontally. It may seem a little nitpicky, but the top dot, I mean the back dot, the one that's closest to the laser, is just a smidge higher than the dot at the front. See that? Alright, so now what we want to do to get an up-down movement, you want to touch this guy, and to go up, which is what we want to do, you want to screw it in. So instead of backing out, you want to screw it in. Check your firing. There. Let me start with a fresh dot. Just move that over a little. One. Dot number 2, right in the center. All right. Now we're going to move our mirror into the path of the beam, because our beam is aligned. The beam from mirror 1 is aligned to the x-axis. Now we're going to bring mirror 2 into the path. So to do that, just make a dot. Alright, and we can see, where is that hitting? That seems to be hitting right in the center, but I can't be 100% sure, so let's see. What's an easy way to do this? I know this is probably going to foul my mirror, but I'm going to put a Post-it over only half. See if I can get that in there properly. So I've got half my mirror blocked. I'm hoping to get a spot right in the middle of that paper. Now if it's reflecting it all off the mirror itself, it may make 2 dots. Where's... oh, I guess I should take that paper off. Also shouldn't get my charger cord in the middle of the beam. Alright, so it's a little high. See that? So my options at this point is I can take the mirror off on the bracket and add a couple more shims, or I need to get my tube to move down. So obviously I don't want to fudge with the tube right now, so I'll put the phone down again. We will shim this guy up. So see, I'm using these M4 screws because I don't have anything better. I mean, M4 nuts. shim up the gantry. Let's see if I can muster a couple more from the spare parts. Here's one. Is that an M4? Yeah. So I'll shim up 2 of those guys. I guess to make all of this as globally accessible to everyone, I'm avoiding recommending that you 3D print something, because I do have 3D printers and I could easily just make something custom for my printer, but the goal here is to work with what you've got on hand when there's nothing else to be had. Let's see, while I'm doing this, I'm going to put a couple of washers on top here. Well, maybe not. Just dropped one of my screws. Alright, so shimming it up that much. Let's see, what size screw do I have here? Oh, I see. Need a longer screw. This is like an M310. Let's see. Of course, you all have assorted M3 screws, right? What do we have here? 12, those are 12 nuts. Those are 8s, 12s. A couple of this guys. A couple of these guys. All right. Alright, so I'm raising the head up to catch the beam. Now, I don't want to give you the impression that that I'm simply satisfied with the position of the laser tube, because now that I know that it's high, when the ZBed comes here today, I'll probably just take the whole machine apart. I'll 3D print something more adjustable for the tube, and get it to the proper height where I don't have to shim up anything to get my mirrors to line up. But again, you know, this is how you would line up a machine like mine that's damaged in shipping. It's not square by any means, and so it does require a bit of ingenuity to bring it into final alignment. I'm not believing this, but it seems like even an M12 is not enough to catch that stepper motor. Is that seriously true? Let me investigate further, because the next size up is going to be like an M16. Oh wow. Alright, so longer screws are needed. Let me get those. You know what I probably did is I probably grabbed the same... No, it's definitely longer than the old screw. Okay. So the M16s. If these don't work, I'm going to get a real M16 and just shoot the machine and be done with it. Just kidding, guys. I'm actually not pro-gun. I'm not anti-gun either, but I'm just not pro-gun. Why don't they just make a phone that you can attach to your forehead for these type of videos? Well, I guess that would be called a GoPro, right? Alright. Once again with the M3 16mm. And yes, that one seems to do the trick. So wow, I really raised, by adding that second nut in there, I raised that thing quite a bit to the point where the M10 screw didn't catch through to the stepper motor anymore back there. Alright, I'll give you guys a look here in a second, but it's just very difficult to screw all this in with only one hand. Hell, it's even hard to do with two hands. There we go. Alright, I'll let you catch the last little bit of it. Alright, so I've added a second set of shims there. You know, I think these stepper motor threads are probably... No, they're not stripped, it's just not catching. Alright, so I've left a little space in there right now, so we should be still misaligned. I'll have to move it over, but let's just see where it hits on the mirror here. Let's see if I can get a better approach to this. I'll just put an indentation around the mirror. Now, you know what? I'm going to check the alignment since we've been messing inside the guts. Let's make sure that the beam is still aligned. And I'll repeat it again. We're just lining up the beam to itself. That is, the two dots are on top of each other without any regard for where the mirror is. Okay, so you can see there the dot's getting darker. That beam is directly on top of itself no matter where this travels, which means the beam is horizontally and vertically aligned with your y-axis rod. Now we'll put that piece of paper back here. Take a note of where that beam is hitting with respect to the center of the mirror. Alright, it's actually very close. Alright, so at this point what I'm going to do is I'm just going to move my mirror back into where I know it was lined up, which is where this bracket touches the frame there. Almost there. Okay, so just to reiterate, and I can't say this enough because I don't see it in mirror alignment videos, you do not want to line up your dots to the center of the mirrors when you're lining up the mirrors. You want to line up the dots to each other, and then you want to bring the mirror into the center of that dot. Okay, that is the correct way to align your laser, and this will compensate for a lot. If you haven't seen the beginning of this video, if you're catching it live, this machine was shipped and essentially partially destroyed in shipment. The frame isn't even square. I took off the door. As you can see, this hinge isn't even there. It's just broken. And there's a few stress cracks where the frame is actually, contorted. So not a real straight machine. All right, so we're gonna get this sucker very well lined up. All right, so I'm gonna put this Post-it on half of the mirror, so we can clearly see where that's landing. I'm going to zap it one more time. Alright, it's still a little high, but I'm going to call that good for now because it's pretty close. It's within a couple of millimeters, I think, of the center of the mirror. So let's move on to alignment of mirror number 2. And just like mirror number 1, what we're shooting for here is not to line up the mirror to the center of this hole. We're not adjusting this mirror to get in here. Okay, that's not the goal. The goal is to get the near and far dots to land on top of each other, so that the beam is coincident or collinear, I guess. Yeah, coincident would mean that they're all traveling together in the same place in space, but these are collinear to the x-axis. So that is, you want the beam to follow this horizontal plane and this vertical plane with an offset, right? It's over here, because that's the path that your mirror number 3 is following. Okay, and here's my 12 millimeter standoff line that represents the center of the mirror from the base here, from this metal base. I've scored a line there, so when I place my 12 millimeter score mark on my Post-it note, right, I'm going to set this guy, it's 12 millimeters. Lock him in. Doesn't have to be close, just I mean, it doesn't have to be perfect, just close. 12.27. I've got my Post-it note here. The sticky side is down here. That's where I'm going to make my score mark. I'm going to put the phone down, so I'll do this properly. I'm just using the caliper itself, right? So I'm doing it like this, scoring it across. And then I'm sticking that guy onto I always forget to do this, okay? I always bend the top so that the paper doesn't sag, because we're not, at least not initially, we're not wrapping this Post-it note around the mirror, and the reason for that is because I want to catch the beam. If the beam is way off left and right, I want to be able to catch it without too much effort. So let's just burn a hole there. Alright, we're slightly above, which is to be expected. And look at that, we're way off in the back. Okay, so the near dot is actually pretty close to the mark that I scored in the middle of the mirror there, but this one is way off. Okay, and it's slightly lower. Okay, so it needs to go diagonally up, but first we need to get it lined up so that this dot is back in its proper location. And to get that left and right movement on the mirror, this is the screw that you want to touch. Okay, this mirror does left and right, this mirror does up and down, this mirror does diagonal bottom left to top right. So I'm actually going to slightly lock these down so they don't move on me too much. Okay, so quite a bit of movement that we need to do there. So I'm going to back that guy out to get movement towards the left. Back him out some more. Okay, you can see we're getting very close now. Be too much. A little too much. Alright, so we're getting some dots there, but again, we're not trying to line up to the center of the mirror, so I'm going to start off with a fresh piece of paper. And this time I think I am going to just curl it around the mirror, because we know we're pretty close. There's no real chance of overshoot there. not very sticky. What do you want? It's dollar store Postit, so. Okay, hole number 1 is way out there. Hole number 2 is there. Again, I'm just trying to line them up vertically so that they're directly on top of each other. That's a little too much. And now, what I want to do is I want to use the up-down, right, because I don't have diagonal misalignment anymore. Bring those two guys into alignment with each other. Alright, so up down to go up, you screw it in. To go down, you screw it out. So in this case, we want to go up. So I'm going to screw it in. I got to back out my set screw. Screw it in slightly and note how much that dot moves up. It's moved up slightly, a little bit more, a little bit more. Change out the paper. Dot there. Now it's slightly higher, so we're going to back out a little bit. Still slightly high. Wait, back out or? No, I'm sorry. Wait, to go down, yeah, we back out. I think we're pretty close there. Dot number 1. Nope. Okay, so dot number 1 is high and dot number 2 is low. So are we splitting the difference then? Oh, you know what it is? Shoot. Well, maybe it is. Maybe it isn't. I only screwed down 2 of the nuts on the gantry. So I could be chasing my tail here. Find out in a second. So, because the 2 nuts that I tightened down are diagonal from each other, I could have introduced some twist into the gantry, and twist is the one thing that you can't compensate for. You have to get the twist out of your gantry by any means necessary, and that the twist means that diagonal corners opposite from each other are at the same level, and the other 2 are higher or lower. Alright, still need to come up a bit. More. Okay. Alright, those are really close. close is not good enough. If you're going to get it to this level, you may as well get them right on top of each other. Okay, I guess I can't say it enough. You're not trying to line up to the center of the mirrors, you're just trying to line the two dots up to each other. And there we go. Alright, so I don't know if you saw that, but it's actually hitting right here on the edge of the mirror. So the adjustment there is to push these guys back. Right, so what we'll do now, I'm going to put the phone down again. I'm going to just loosen those 3 screws that are holding down the lens. Just enough so I can move them. And I'm only going to move it, let's see, it was hitting on this side, so I'm going to move it about 2 or 3 millimeters. Right there. Tighten these guys down. For those of you that didn't see it before, there is a score line that roughly lines up with the center of the hole, so that when I put my Post-it note down, I know where the center is without having to, like, you know, press into the Post-it or anything like that. So that gives me my horizontal alignment. Left to right, I can see if the hole's hitting in the center. And then, of course, the 12 millimeters from the base is where you want the beam to hit. Alright, so let's see there if I can catch the cut. Where is it? So it's about a millimeter. It's about a millimeter off center. Still off to the left. So we want to bring the whole thing 1 more millimeter in. Strangely enough, the screw marks on this plate suggest that this was the original position of this guy. So the last time that I took the scantry off and straightened out the frame and got everything lined up, I must have had the laser tube in a different orientation. When I push it down this morning, it must have gone back into its original position, or closer to its original position, and I have to assume that they probably did some type of alignment at the factory, and it must have been fairly close, because now I'm finding that aside from the laser being too high, everything else seems to be going back to the original positions, where I have screw marks from the plate's original installations. Alright, so that's dead center. You can see it, let's see. Okay, but it's probably not at the 12 millimeter mark. Let's see where it is. So it is above the 2 millimeter mark. Okay, so that would suggest that we need to raise this guy even higher. Right, because now our beam is aligned. That is, we're getting the 2 dots hitting on top of each other, but let me see if I can make an indentation in the top. Alright, so you can see that semicircle there. Let's see where the laser hits relative to the top. See, so we're hitting right there at the top now. The mirror in the back is 18 millimeters, and that's plenty for it to get down to the lens. But again, you know, we may as well get it as close as possible. So I think shimming this guy up by another millimeter would be great. It's just a matter of whether or not I have more washers available. Let's see. You know, in the end, this really is going to give you the most effective cutting power. Having this kind of alignment, not settling for the spots just being close, is really going to go a long ways to getting you the best cutting. Shoot, I don't think I have any more. Surely there's washers in here somewhere. Or M4s, M3, M4, aha. This is a bit of a hack, I agree. Ideally, I should get some nylon standoffs or something, but when I install the bed later today, I think all these adjustments are going to go out the window and we'll just do the thing all over again. Alright, so we're going to add, these guys are about 3-ish millimeters in thickness. Alright, let me see if I can prop this phone up somehow. At least give you a looky look at what I'm doing. Can you see that right there? Not really, right? I'll do my best. So those 4mm nuts that you saw me pick up, I already have 3 of them stacked on top of here. And that just shows you how misaligned this machine was when I opened the box. And I have to grab those longer screws again, the M12s, I think. Sorry, not M12s. M3 12s. M3 by 12s. Okay. Start with the back one. Oh boy, this is going to be a challenge. Yeah, if you have a 3D printer, I say go for it. Make all your parts with the 3D printer. But obviously not everybody has a 3D printer, so you got to make do with what you've got. I've got some M4 nuts, so that's what I'm going to use to shim these up. What happened to the other two? I dropped them. Oh, I need one more 12mm length M3. Okay, so with any luck, we're in the home stretch here. Once we've positioned the nozzle in the center of the beam, assuming that there's no twist in the nozzle itself, we're going to have a fairly well aligned laser here. Getting these last M4 nuts in here is going to be a bit tricky. You know what? For the sake of shortening the video, I'm going to leave those two guys off for now. take a look, see where our dot is sitting these days. Let's not leave the phone there. Whew. I think that's right on. All right. On. Look at that. Good enough, right? Yeah? No? Maybe? I say that's good enough. All right. So, with a couple of exceptions, one being that I haven't put my two shims, quote unquote, in there, and only this nut and the diagonal are tied down, this bed is properly aligned, and it's accomplished by not trying to align to the centers of the mirrors, but aligning the centers of the dots to each other, bringing the mirrors into alignment with that existing beam alignment, and then doing the same thing for mirror number 3, aligning the beam to the horizontal and vertical of the axis, and then bringing the mirror into position where those two dots are. Alright, so I hope that this video gets a lot of circulation to all you guys out there that are having difficulties getting your machines to cut optimally. I hope it benefits the community in general a lot, because I've seen a lot of, I won't call it misinformation, it's all good intended, but again, the proper way to align a mirror is not to attempt to align the laser beam to the center of the mirror, but to align the beam to itself relative to the axis that the mirror is traveling on. If anybody out there wants to turn this into some type of infographic, I know this video is quite long, please feel free to do so. Alright, I hope you all have a good day. Later today my ZBed's going to be coming in, so I may take all this apart again and do another live feed and just sit there and put it together. Alright, have a wonderful morning. Oh, I see I have some questions here. You make it look so easy. Yeah, it's not easy. Came in late. What size metric hex head bolt is he using? Oh, those are M3s. I've mentioned that, I think. So yeah, laser uses M3s. There are some M4s here. Okay, so if you need to replace these guys, those are M4s. And I did replace mine because the screws that were there were pretty crappy, and they weren't actually long enough. You know, this machine was actually sent to me broken. I was not the original owner. The original owner received it broken, decided he couldn't fix it, and sold it off. And I bought it. The belt had broken in shipment also, and it looked like he had cut it down, and it was no longer the right length. So I needed to stretch the tensioner in here slightly, so I put in longer screws there. What else? Oh, I wish I could go home now and try after seeing this. Yeah, I'll definitely save it. I'll probably do a more concise video once I have the ZBed installed in here, since I'm gonna have to realign everything again. But I'll definitely post this so that we can all reference back to it. Yeah, so the lengths of the screws, at least in my case, I don't know if you caught this part of the video, but I've got this shimmed up with a couple of M4 nuts underneath, so that's about 6 millimeters that I had to add on. But lengthwise, okay, so again, I have my plate here shimmed up 4 millimeters, and I'm using an M3 16, so these are 16 millimeters long, which means you've got to go through 6 millimeters of shimming, also the little washer that I put on top. You've got another 5 millimeters or so of aluminum plate, and then you need to get into the stepper motor, and I think stepper motors have 5 or 6 millimeters of depth in the holes. That's kind of standard. So anything within that length range will work. The minimum, I think originally I had M3 10 millimeter length screws in here when there was no shimming whatsoever. But those were the original M3 screws. They're kind of like these here. I think these are M2.5s. But yeah, the original, let's see if I saved any of those. I think these were some of the original screws. Yeah, you can see they're, you know, high grade titanium. No, not very good. Alright, well, since I've got 6 of you online, I guess I could talk on a little bit more. So you can see me ripping the aluminum out of here. You know, for airflow purposes, you know, this machine is pretty stock, and I've kept it that way on purpose. I don't necessarily agree with all of the modifications that a lot of people do immediately when they get the machine. I guess I should say I've repaired a lot of these for friends before I bought my own, so I'm fairly familiar with them. But you'll see my blower there is the original stock, and what I did is I took some of this foam board, right, and I cut out a template and put it on there so that you know, the opening here is exactly the same size as the opening on the back. The foam makes it a nice tight fit against the rest of the machine, and so you get maximum suction from the, you know, arguably the crappy blower. I like the blower, it seems to work fine for me, but yeah, making the opening just the right size really helps suck all the air through. But if you have other openings in your machine, like the hole in the bottom, this is these machines at some point were included with a manually leveled bed that you could reach underneath, and the knob was there, and you would turn it and it would raise and lower the bed. But it wasn't very well built, of course, and you know, they've redesigned these machines many times, and this last iteration, the machine didn't come with that bed. It comes configured to cut rubber stamps, so I took that out as well. Now this hole here, the reason for this hole is that they used to include a light bulb inside there, and that's how you would illuminate. Now they've moved it to an LED strip on the back, so you would want to seal off this compartment as much as possible to get as much as close to laminar flow as you could from this side to that side. And if you look at the machine designs, some of them have these little vents on the door. What I prefer to do is I put a little gap, you know, just put like a 1/2 inch or a 12 millimeter bit of something here to keep that door open, and then I get flow across the part. It goes into the vent, and all of the smoke gets blown out quite effectively. I wonder if I should put this thing back together. Should we cut something? Anybody have an opinion? I can pop these guys in temporarily, and yeah, what the heck? Let's cut something. See what my alignment has wrought. So yeah, these are just some 3D printed standoffs, and their length is such that it puts the laser at the right distance to 3 millimeter material. Of course, I've shimmed up my head here, so it's another 3 millimeters or so off the bed now, so it's probably not gonna be in focus with this thing. But well, let's just see. Won't matter after this afternoon. Once that bed comes in, I can cut anything. Alright, we'll just use a piece of paper for now just to check the line quality. Let's see if we have something queued up that can easily be sent. Damn kids, man. Turning off my computers to save power. Jeez. Alright. Now let's check dots on the corners. Whew. That one's really sharp. Yeah, so when you're testing like this, what you're looking for is to get a nice round dot, not anything with geez, those are really tiny. If you're getting half moons and you have the air assist nozzle that's metal, you know, the one that's like a cone. If you get a little half moon on your cut, that means you're hitting the edge either on the nozzle itself or you're hitting an edge on one of the mirrors further down the line. But yeah, with the exception of that, I think I hit that one a little too hard, but man, these are the smallest dots I've seen, especially that guy. It's a really nice sharp edge. Alright, password. Let's see, don't want to share that with the internet. Let's see, I did a little spiral thing the other day. Let's see if I can load that up. Open. Today I'm using K40 Whisperer. I have to admit, it's not my favorite program. I actually like the original software that came with the laser, primarily because I find that I can't really go too fast with K40 Whisperer. Does anybody else have any opinions about K40? Like for example, if I'm doing an engraving of the full size here with the original software, I can easily go at 400 millimeters per second. And you know, do this whole thing in maybe 35 minutes or so. With K40 Whisperer, if I go anywhere above 100, I get these little stalls where it has to refill its buffer. Like let's see, let's do a raster engrave of these spirals. See those guys? Probably need to turn up the laser. 9, 10. What do you think about 16? My litter of burnt Post-its. Yeah, another thing that troubles me about K40 Whisperer is the amount of time. Is it even going to cut? Is it? Home. Hello? Yeah, communications are a little squirrely with it. Home. And what is this? Vector engrave. Let's do it at 100 millimeters. Nice little flame there. Go down the tower. you're done. So yeah, the laser itself is aligned, but the enclosure obviously misaligned to hell and back. Alright guys, I'm out of here. We'll see you later.